All right, this will be your last worksheet specifically on implicit differentiation. When we get to Monday, we're going to talk about stuff called related rates. Once we get through related rates, we'll be ready for our next test.
Oh, no.
And so our next test is going to cover position, velocity, acceleration, implicit differentiation, and related rates. That's what's going to be on your next test. All right, so I'm not going to give you anything new on implicit differentiation. You've already got everything. But there is another type of problem that might show up on the AP test, and that's what we're going to look at today. Okay, and it says, the directions say we are evaluating limits by recognizing that the given limit represents a derivative. That's what we're trying to do today. So A, B, and C are going to be examples we work together, and then the back side of this worksheet will be your assignment for today. Okay? But again, it says we are evaluating limits by recognizing that the given limit represents a derivative. Why does that represent a derivative?
Because usually the limit of the difference in the course.
All right, thank you. Very good. As Chris said or mumbled,
The limit of the difference quotient.
this right here,
That's just
the problem we have right here is in that form. Okay, we're in that form. So when I see a limit like that, it's not wanting me to work that limit out, because you probably won't be able to work it out. Okay, well, actually that one you can work out.
Oh, yeah, I do.
So you can spend the time to work out. But if it shows up on an AP test, they're probably going to give it to you in a form where you can't work it out. And your job is to understand that when I see that, that's really asking me to do what? Find the derivative is what it's asking me to find. Okay? So, to be able to find the derivative, I first need to figure out what is it that I need to find the derivative of. So, on this problem, what is it that thing's trying to find the derivative of?
Negative
Two.
2x cubed. Okay? We're trying to find the derivative of f of x, and if you notice, f of x is over here on the right. So, in this problem right here, what's f of x?
2x.
2x cubed is f of x. So if I work the limit of the difference quotient, that gives me the derivative, but I can use my derivative rules to find the derivative of this thing. And I can understand that this is equal to 6x squared, so this thing up here is equal to 6x squared. So the main thing we're trying to do is we're trying to get you to recognize that if you see something in the form of the limit of the difference quotient, as h is approaching, what does h need to be approaching? 0. That's what you're trying to find is the derivative of the function. So let's look at B.
That's all you have to do on that one?
That's all I've got to do. My answer would be 6x squared. Your job is to identify the function and then find the derivative. That's what we're trying to do here.
Well,
So, on part B, limit as h approaches 0 of cosine of 5 times x plus h minus cosine of 5x over h. What's my function?
cosine of 5x.
Cosine of 5x. So once I identify my function is cosine of 5x, then what do I want to do? Find the derivative. What's required on finding the derivative of this? The chain rule.
Man.
Okay? The chain rule. So what's my outside function?
Negative sign. You have to write the derivative.
Cosine is, but then what's the derivative
Oh,
of
it's
cosine?
negative.
Negative sign. What happens to the inside? Stays the same, and then I need the derivative of the inside. So what this problem is looking for is negative 5 sine of 5x. That's what it's looking for. Question so far?
Yeah, let's just have that one. Right?
On C, yeah, C looks a little funky. They throw a little curveball in there.
I like
Look at C and tell me what's going on C.
But it stays
you're
back
taking the
there.
derivative of sine of pi over 6, you just do the answer. So they gave you.
They gave you a number, and you gave
You've
it.
got seem to have two different values right there. No, the sine of pi over 6 is 1/2, but they can't work that. Oh, I see. So it's that minus sine of pi over 6 is 1/2.
All right, so what's going on here?
Your f of x.
How is this different than the first two?
Because they gave you the and, they gave you not the same thing.
This one is finding the derivative, but it's also doing something else. What is it doing after you find the derivative? Plug it in and
Sorry.
Number,
what do we usually do once we find the derivative?
plug in.
Plug in what?
X value.
An x value. And what does that x value give me?
The slope of the tangent.
The slope of the tangent line. So this one right here is going a step further. It wants you to find the derivative, but it also wants you to plug in at a specific x value. Okay?
Man.
So this one, again, let me throw my limit of the difference quotient up there, which is this over h. Now, on the first two problems, we looked over there to figure out what f of x is. But on this one, it's no good to me because what's over there? Just the constant. So that means I need to come to this side, and I want to use this side to tell me what f is. So if I look at this side, I need to figure out what two things are. I need to figure out what my function is, and I need to figure out the x value at which we are evaluating our derivative. So look at f of x plus h, and then look at sine of pi over 6 plus h. What's my x value? What's in place of x up here?
5 or 6.
Pi over 6 is in place of x, so that means this is pi over 6. Okay, so that means the pi over 6 plus h, I need to replace that with what? To get the function. What do we put x plus h in for if we're working this out? If we're finding the limit, what do we usually put x plus h in for? X. So if I'm doing the reverse, I want to take the pi over 6 plus h out and put what back in its place if I'm trying to get to the original function? X. So if I take that out and put x in its place, what's my original function? Sine of x. So now I can get my derivative and then I can evaluate it at my x value. Just give it to me on Monday because you see me before you go to lunch, so it doesn't matter. All right, so the derivative of sine is cosine, and I want to evaluate it at pi over 6. So cosine of pi over 6. Cosine of pi over 6 is, so that means this limit up here equals radical 3 over 2. So there are two places I can look for my function. If we're not plugging in an x value, where do I look? On the right side. If they've got an x value plugged in, where do I look? On the left side. And how do I figure out what my function is? I take out the number plus h and put what in its place? X. Okay, so in this case, there's a 1/2 on the right, so that does me no good. I look over here, I take the number plus h out, I put x in its place, that gives me sine of x, then I take my derivative and plug in the x value. Okay? Questions on that? That's more of a concept. These are more of a concept problem than they are difficult problems. Okay? Once you understand the concept and know what to look for, it's pretty easy. Alright, so turn that over. There are the first 4 are like what we just did, and then everything else is implicit. So you've got about 12 minutes to work.